Yeah. Okay, so let's quickly look at the mirror formula. Now we have 1 over f equals to 1 over u plus 1 over v, where the f is the focal length of the mirror and the v is the image distance from the lens. Then u is the object distance from the lens. Now let's say this length for, and if the f, this is the c. If my image is here, if my object is here, the distance between this object and my lens is what we call the u. That is the object distance. We know that this image, the image of this will be formed at the bound of this, will be formed behind this. Now, this is the image. The distance between the image and the lens is what we call the image distance. This is the object height, and this is the image height. A question that reads this, okay, for the first example that I gave you, let's look at it together. It reads us, an object is placed 5 centimeters from a converging length. Before I go to this, we have to note this. But we are using real is positive. Real is positive. That is, if you have a converging length, number one thing, for converging length take what? Plus f. Do you get that? Do you get that? Diverging length, or which we call what? Convex length, take minus f. Real object always take what? Plus u. That means it's positive. Real image take on minus d. No, plus d, sorry. Then virtual image take on minus d. So once you understand this concept, now the next thing is for you to understand an object is placed 5 centimeters from a converging length. What are we talking about? What is that? The u. So we are talking about what? So let us do that example 1. Let us bring out our value. U equals what? Plus 5 centimeters. Do you understand? To make it possible because it's an object. The object is real. Right? So it plays 5 centimeters from a converging length of focal length 15 centimeters. Of focal length 15 centimeters. How are you going to put that? Focal length. Is it positive or negative? Why is it positive? Because of the converging length. So we are going to write plus what? 15 centimeters. Are you getting it? Find the nature, position, and magnification. What's the nature? We want to know if this object is going to produce a vector image. That's the nature. The position is telling us that we should look for what? The distance. That's image distance. We already have u. We already have f. So we are looking for v. What are we going to use? Using what? Middle formula 1 over f equals 1 over u plus 1 over v. And we're looking for v. Bring it to this side. We have 1 over v equals to 1 over f. Take this on this side. Minus 1 over u. What's 1 over f? That's 1 over 15 minus 1 over 5. What's the LCM of this? So 15 in 15, 1, 1, 1, minus what? 3. So So we have 1 over b equals to minus 2 over 15. And this b will give us minus 15 over 2, which is what? Minus 7.5 centimeters. What? This minus that is in front of this 7.5 tells us that what? The image, the nature, the image is virtual. 1. That 7.5 means that what? The image is 7.5 centimeters behind, no, it's 7.5 centimeters here, behind the mirror. Because a data, are you getting it? Is at a negative distance, 7.5. It's not, I think I'm using behind. So you understand? Now, that is how to solve it. So, we have told them that what? It is behind it is 7.5 centimeter behind the mirror. Or we can just say, okay, so just note, whether it's length or mirror, we use the same thing. Are you getting it? For length and for mirror. So they are still on mirror. So it's everything converging mirror, diverging mirror, no length here. So just note that. The question was even for a length. So let us not write behind the mirror here. Let's put it in the length. So 7.5, that the position is what? Let us write position is 7.5 from the question length, right? From the length. So let us just use that length. So okay, now number 2, let's look for, they also asked us to look for the magnification. What will be the magnification now? M equals to V over U. What is our V? 7.5 over U is what? U is 5 now. So what's 7.5 divided by 5? That's 1 point what? 1.5. M is 1.5. That means the image is 1.5 times bigger than the object. That's the meaning. Let's look at another question. A concave mirror. Example 2. A concave mirror of radius of curvature (20 centimeters) produces an inverted image. 3 times the size of an object placed on the perpendicular axis. As placed on the perpendicular to the axis. Calculate the position of the object and the image. Now, this question is a concave mirror of radius of curvature. Now, listen, we have to note the solution. They gave us radius of curvature as what? 20 centimeters. A concave mirror is also known as what? A converging mirror. Therefore, it will also have a positive unit of curvature. And how do we get that? Because R equals what? 2F. So I know I need this F. I need to calculate my F here. So F equals to R over 2, which is 20 over 2. What we write? Plus 10 centimeters. That's the focal length of the mirror. The next sentence there now says produces an inverted image. You know, if for concave mirror, do you remember when we were drawing the diagram? All the diagrams that we drew, apart from one, we all had what? Inverted images. Do you understand? That means they are what? Real images. The only one we have in erect image, which is a virtual image, is between F and the pole, between focus and the pole, right? So in this case, if it is an inverted image, that means our V is what? Positive. Our U is also what? Positive. But it also does that an inverted image 3 times bigger than what? 3 times the size of the what? Object. That means that what? Our V equals what? 3U. Do you understand that? The image that was produced is 3 times the size of the object. Right? The distance of the object. So that's 3U. In this case, so we can say V equals what? 3U. Now, let's calculate the position of the object and the image. In this case, so we can use what? 1 over F equals to 1 over U plus 1 over V. So we have F, we have U, we don't have U, but we have V. So let us put it 1 over what? What's F? 10 equals what? 1 over U plus 1 over what? 3U. Do we understand? And this will give us 1 over 10. This will equal to what? 3U, right? U in 3U, that's 3 plus 3U in 3U, 1. So we have 1 over 10 equals to 4 over 3U. So 3U equals to 40. Therefore, U equals to 40 over 3. And that will give us 13.3 centimeters. That means the object distance is 13.3 centimeters. Then we can also come from V. From V equals to 3U. V equals what? 3 times what? 13.3. What's that? What's the answer? What is it? 40.0 centimeters. So that means, look at this. Look at this image. Look at this question. If you analyze it, who can tell me where was the object placed? Is it at C, between C and F, between C, beyond C? Look at it. Look at the where? No. If the object was at C, it would have produced what? Same size, 1, same distance, 2. Do you understand? Though it's going to be inverted 2. But look at F. The F value here is what? 10 centimeters. And the U is what? 10 centimeters. That means the object was placed in between C and F. The object was placed in between C and F. Because F is 10. The distance of the object is what? 13. And the image distance is what? 40. You see, because if it was C, C would give us 20. So it is far from C. Do you understand? And that's what you need to understand in this? Well, let's see if we have a question on. Okay, let's take the last one on convex mirror. Example 3. An object is placed 15 centimeters in front of a convex mirror, and an image is produced 5 centimeters behind the mirror. Calculate the length, the focal length, the focal length of the mirror. Calculate the focal length of the mirror. Now, what are the givens here? Number one thing, an object is placed 15 centimeters. What is that? 15 centimeters in front of a convex mirror. What's that? U equals to plus 15 centimeters. In front of a convex mirror. I know that the image produced by a convex mirror will always be what? A virtual image, erect image, and magnified image. That's why I gave you the code. Virtual, erect, magnified. Sorry, the meaning. That's for the other one is when it is, where do you have it? Where do you always have that virtual? At least we know that it will always be virtual when it is placed between F and P, right? So let us not disturb ourselves too much. Convex mirror, an image is produced 5 centimeters behind. What is this? What's that 5 centimeters behind? That's our B. Image produced. Then an object is placed 5 centimeters in front of it, and image is produced 5 centimeters behind. That means B is what? Minus 5 centimeters. Do we understand? Behind the mirror. Calculate the focal length of the mirror. So we have 1 over F equals 1 over U plus 1 over B. 1 over F equals to 1 over 15 plus 1 over minus 5, which will give us 1 over 15 minus 1 over 5. And that is the 1 over F equals to 15, 1 minus 3. Right? F equals to 16 over minus 2. And F equals to minus 7.5 centimeters. Oh, are they the same? Oh. So, in that case, so we can say that this is a virtual focus. It has a virtual focus.